Let us begin with today's meet. Today on 10th of March, we all are here to continue with subject physics. Earlier we started chapter based on current electricity, chapter number 11. We'll continue with the same. Last time we discussed about Ohm's law. Okay, I will try. Now are you getting my voice clear? Are you getting my voice clear? Okay, fine. We'll continue with the discussion. Ohm's law, we have considered Ohm's law. Mathematically, we can express Ohm's law by equation V by I is equal to R. So any good conductor, even though highly sensitive for passage of electric charges through it, hello, hello, this is the sound clear? I will continue. I will continue with the meet. I'll continue with the meet. So using Ohm's law, even the conductor is highly sensitive, each good conductor offers certain opposition for the passage of charges through it and offers certain resistance for the passage of charges through it. So for given value of voltage, it allows only certain value of current through it. Based on this, we can solve few numerics. I will dictate, listen carefully. When potential difference of 3 volts is applied across the conductor, current obtained through it is 2 ampere. So value of voltage across that conductor, given conductor, if I take 3 volt, through it the current passes of 2 ampere. So it allows only 2 ampere current to pass through it when potential difference of 3 volts is maintained across its terminals. They have asked what would be the current through the same conductor by keeping all the other parameters constant if potential difference of 5 volts is now applied across it. So you are not changing the dimensions of the conductor, nor changing the surrounding setting, that is temperature, material of the conductor. Only the potential difference across end is changed. Now in other case they have made V2 is equal to 5 volt. And they have asked you now how much current it will allow to pass through it. So directly this sum can be solved using the mathematical expression of Ohm's law. So resistance of given specimen wire never changes because physical conditions all other we have kept constant and R is a constant value. So if voltage is V1, current is I1. If voltage I made V2 without changing R of the conductor, what will be the value of I2? So you can equate V1 by I1 is equal to V2 upon I2. So I2 will be then, this will go up, I1 will come up V2 into cross multiplication I1 upon V1. So with this formula, you can find value of I2 easily. Only when you apply Ohm's law, all other parameters of the conductor should be kept constant. So this is application of Ohm's law. You can use this relation assuming the conductor under consideration is ohmic one. Ohmic conductor, for ohmic conductor, when V is increased, I increases in same proportion. So we can equate V1 by I1 with V2 by I2 because for given specimen R does not change when its all other parameters are kept constant. So this such type of numerics for 1 mark or for MCQ type questions can be said based on fundamental law in electricity, that is Ohm's law. Sometimes they may ask you the numeric the other way. For example, I will read the numeric. Listen it carefully. A conductor carries a current of 300 milliampere through a given specimen conductor. They have one conductor. It carries the current I of 300 milliampere. Number of electrons passing through it in 1 minute, we have to calculate. They have asked you by giving the value of I, find the number of electrons N passing through that conductor in 1 minute. What is the time given? 1 minute. N is number of electrons. So what is current? Current is rate of charge with respect to time. So net charge passed through given area in unit time is nothing but current flowing through that conductor for that particular time. So current is passed for suppose 1 minute. So total charge passed through it will be I into T. So you can determine. So when current I of 300 milliampere passes through conductor for 1 minute, the total charge through the conductor which is passed will be I into T. I is in not SI unit. We expect the last answer in standard unit. Charge should be in coulomb. So current should be in ampere and time should be in second. So milliampere, it is the fraction of ampere. To convert milliampere into ampere, you multiply it by 10 raised to minus 3. Before substitution, you have to convert all these values in their SI unit. So Q will be in its SI unit. 1 minute in second is 60 seconds. So 6 3s are 18. 1, 2, 3. So 10 raised to 3 into 10 raised to minus 3. Both will get cancelled. So net charge flow through the conductor will be 18 coulomb. They have asked to find number of electrons. This is first step. Now we'll proceed further for the second step. So one electron has charge of 1.6 10 raised to minus 19 coulomb. So 1 in 0.6 10 raised to minus 19 coulomb corresponds to 1 electron. So this much charge has flowed. So 80 coulomb charge if has flowed, how many electrons pass through the given conductor? So this is the second case. This much charge corresponds to 1 electron. So this much charge corresponds to how many electrons? Then we can write N as 1.6 18 into 1 upon 1.6 10 raised to minus 19. So this will be 1.6, I could write 16 by shifting decimal one digit to the right. So 18 now will become 180 because you have multiplied denominator by 10. So to make them equilibrium, you should multiply denominator by 10. So it will become 180. So 10 raised to minus 19 will be 10 raised to plus 19 if taken in numerator. So 16 ones are 20 ones are. So nearly 11 into 10 raised to plus 19 number of electrons have passed through the conductor through given area of cross section when it allows current of 300 milliampere to pass through it for 1 minute. So all these charges flow only in one particular direction and all these charges are of same type. So they constitute the current. So based on definition of current, such type of numerics can also be said in exam. So this is the basic. Depending on Ohm's law and depending on definition of current, such numerics can occur. We'll proceed further for the next point to be studied theoretically. So we considered resistance R. This resistance R for given specimen wire. If I have number of pieces of wire, suppose all made up of same material and all these have same thickness. Then each piece even made up of same material, even have same area of cross section, that is thickness, being different in lengths, have different values of resistances. We have to define resistance for given particular wire. If the specimen wire is changed, if you select another wire, irrespective of same material, same thickness, but change in length, that time you will get different value of this R. Similarly, if you take different wires having same area of cross section, having same thickness, having same length, but made up of different materials. One is of aluminium, other is of copper, third is of silver, or any metal which is considered as good conductor. Even in such case, for all these three specimens, values of R differ from each other because material is responsible to get the value of R. So different factors affect on the value of R. So for the given specific wire, you have to define its resistance value. Different wires have different values of resistances. Similarly, if material is changed, if length is changed, if you take two wires of made up of same material, of same length suppose, but of different thickness. This is made up of copper, lead has length L. We take the other wire made up of copper only. Length we will keep as it is L, but we will take its area that is thicker. In the other case, its diameter is changed. So area of cross section pi r square also has change. In this case also, if you keep their temperature even constant, many factors affect R. Temperature, material, length, area of cross section of the given specimen wire, all these affect the value of R. More the thin wire, thin, not thick, it gives you larger resistance. Means suppose made up of copper, have same length, maintain at same temperature. Even that time, value of resistance of this piece A will be different from value of resistance of piece B. So R1 will not be same as R2 because its thickness has changed. Similarly here in this case, if you have same material, same thickness, same temperature. Only I have changed the lengths of both. Both are made up of aluminium. Both have same value of area of cross section. Means their thickness is the same. Their temperature is the same. Even that time, since their lengths are different, resistances of wires A dash and B dash have different values. So R is called a macroscopic quantity. It depends on various factors. So the question can be said, explain how resistance of conductor depends on various factors. Hence define its specific resistance or resistivity. Obtain its SI unit. Such 4-mark long question can be said on these are assuming it is macroscopic, depending not micro, it is macro, depends on various parameters. So now we proceed further to study the relation of resistance of given conductor with its different factors. It is observed experimentally. Resistance depends on length. Resistance depends on temperature, on area of cross section, and on material used to prepare the given conductor. So we will consider all these factors one by one. But when you study resistance dependence with any one of the factors, all rest should be kept as it is. Others should be kept constant. Means if you want to find the variation of resistance on length of the conductor, you have to select number of conductors having same thickness, having same length, having same temperature and made up of same material. Then and then only you can relate these two. When you want to study dependence of R on area of cross section of the material, we have to consider different conductors. But when you choose number of conductors, they should be made up of same material. They should be kept at same temperature. They should have same length. Their length should not be changed. You are studying dependence on A. So you select different pieces of conductors of different thickness so that area A of cross section will be different. When such is the case, it is observed experimentally R is proportional to L. So in this case, if I have two pieces of same length, same material, maintained at same temperature and having same area of cross section, the resistance of piece A is observed less than resistance of piece B. Means if the length is increased, resistance of the conductor also increases. So we get the relation R proportional to L. Similarly, when we check relation between R and A, it is inverse proportional to area of cross section. Means here, if I take 2-3 pieces with keeping their lengths same, only you are expect to change its diameter, its thickness, so that area of cross section will change. Material you are not expected to change. Temperature you are not expected to change. It is observed R of A dash and R for B dash is different. More the thick, less is the resistance. In this case, RA dash becomes greater than RB dash. It is experimentally proved and hence we get relation R proportional to 1 by L. When you combine these two, we can write R proportional to L divided by A. On this, the questions can also be said. I will read numeric. Resistance of 2 meter long aluminum wire is 7 ohm. What will be the resistance of 8 meter long aluminum wire having same area of cross section? We get relation R proportional to L. Area they have not changed. So we will consider this relation. First specimen wire is made up of aluminium. Other specimen wire is also made up of aluminium. They have not changed the material. If not mentioned, you have to assume both are maintained at same temperature. So when length is L1, 2 meter, the wire has resistance 7 ohm. Means I have one piece of aluminium wire of length 2 meter. Its resistance that time is 7 meter. Now what they have asked, if I select other piece of aluminium having same thickness, not changing the area of cross section, only the length is made 8 meter. What will be its value of resistance R2 for this specimen wire? For that, we will use relation R proportional to L. That is, length is increased, R also increases. So, for length L2, resistance will proportional to L2. For length L1, resistance R1 will be proportional to L1. Taking their ratio, I could write R2 by R1 is equal to L2 divided by L1. By knowing initial resistance for length L1, length of specimen B, you can find its resistance R2. That will be R1 into L2 upon L1. L2 is 8, by 2 will be 4. 4 into resistance 7 will be then 14 ohm. Such numeric can also be said based on the relation R proportional to L. Similar, MCQ can also be asked on the same. So we are finding the relation R proportional to L by A. If proportionality is given with constant and equal to sign, then I could write R is equal to some constant of proportionality L upon A. This constant of proportionality is called specific resistance. Its symbol is rho. So we can write R is equal to rho L divided by A. Using this equation, we can define specific resistance. In other words, it is also called resistivity as Ra divided by A. This resistivity is defined for given material. Suppose I have wire of copper of length L and area of cross section A. Then resistance of this entire piece, let be R. I have taken one copper wire length L, area of cross section A having resistance R. Then what is rho? If A is made 1, L is made 1, rho will be equal to R. So specific resistance is nothing but resistance of wire made up of same material of unit area of cross section and having unit length. Means what? If you select unit length and if you keep A is equal to 1, then resistance of this specimen wire of copper will be specific resistance of copper material. So copper material, so resistivity is defined for the given material, not of the entire piece or not for the given specimen piece. It is the resistance of given material of unit length and having unit area of cross section. Means if you have one copper cylinder of volume, because area into length will be volume, AL is B. If A is 1, L is 1, volume will be 1. So if you take piece of copper material of unit volume in SI unit, its resistance will be its specific resistance. So you can define specific resistance. What will be its SI unit? R is expressed in ohm, area is expressed in square meter, length is expressed in meter. So meter and square will get cancelled. So specific resistance is expressed in ohm meter. It is its SI unit. So, by studying dependence of macroscopic quantity R on different parameters, we can define specific resistance. This specific resistance is defined for material, not for any given specimen wire. For wire or for the piece of conductor, you define R, and for the piece of material of unit volume, we define its resistance with specific resistance. So this is one more aspect of specific resistance. So if I want to prepare the resistance of 10 ohm, suppose the available material is copper. I have one copper wire. I have to select its length. I have to select its thickness. And I have to prepare the piece from this material wire, which will give you a resistance of 10 ohm. Then to prepare the specimen wire from such copper material, which gives value of 10 ohm, you have to select its length. Its specific resistance is known to you. This relation. I know value of specific resistance of copper. For R is equal to 10, how much length should be selected of given area of cross section? So you can prepare resistance of required value by considering the wire of given material if its value of specific resistance is known. Such resistances prepared are called wire wound resistances. So to prepare wire wound resistances, we have to prepare these pieces of given resistance. So numeric can be set on such formula also. I will read one. Listen carefully. A constant wire has length 50 centimeter, diameter 0.4 millimeter. They have given material as a constant. I have the piece of constant wire. It has length 50 centimeter and has a diameter 0.4 millimeter. I will just wind up. I will conclude. What will be its value of R? If its resistivity given is 5 10 raised to minus 7 ohm meter. Constant wire resistive means what? If I take constant wire piece of unit length and unit area of cross section, this piece gives you resistance of 5 into 10 raised to minus 7 ohm. एवढ्या पीसचा रेजिस्टन्स एवढा आहे. मला ह्याच्यापासून 10 for 50 centimeter length funny and area of cross section you can calculate pi r square. तर या पिचच्या r ची किंमत किती असेल? What will be the value of r for this given specimen piece? Try to solve this example at home. Because time is up, so I am winding up the meet. I am closing the meet for all. Next time we'll discuss more about this specific resistance, how it is useful to prepare uh, wire bound resistor.